Cool, okay, it's working. Alright, so this is the real chain man. So I'm solving this problem today. Problem of the day, first unique number. So my strategy is basically, okay, I guess I should go over the problem. Okay, so you have, okay, so you want to find the first unique number in a queue of integers. So anytime they repeat, it won't work. So like if you enter your queue as 2, 3, and 5, the first unique number is 2. So if you do show first unique, it should return 2. If you want to add a number to it, like you add 5, now 5 is not unique, it has a duplicate, and 2 is still the first unique, but if you add 2 to this, then your first unique number will be 3. And then if you do this, you have no first unique number and you return -1. So okay, so I get the general idea. So my strategy to solve this is to actually use, because I wanted to practice it too, this data structure is a doubly linked list. Basically the idea behind it is that in a doubly linked list you have a self.head and a self.tail. And basically if the linked list will contain everything that is not everything that is unique. So as soon as you get a number which is not unique, I'm going to remove it from the double linked list. And then in order to show the first unique number, it's going to be simply just the self.head.value, or whatever the value is for the head. So basically the head, if I have a double linked list like 2, 3, 5, would be my double linked list for the queue with the 2, 3, 5. For that, basically, I would the head would be pointing to the 2, and well, the val would equal to 2. Now, if you start adding numbers to it, like you add 5, you remove 5 from your double linked list, and then you eventually remove 2, so it becomes 3, and in that case, now your self.head.val will be equal to 3. So that's the general idea. Go about this, and also I'm going to use dictionaries because they have constant time complexity, so that'll increase the ability to solve this. So okay, let me go into it. So first thing I'm going to do is make a class for the nodes, for the node. So I'm going to create a class. Class node, definition, init, self, usually, yeah, I'm going to call it value int. Okay, and then, so that the data that's going to be stored here will be self.next equals to none. That's what it will be initially. Self.prev equals to none because it's a double linked list, so it points to the next and it points to the previous. And then self.data equals to the value. Okay. And then if we go here, so this one's really easy, or not easy, but this one's pretty basic. So, well, actually, first I'm going to create the stuff I want to initialize. So I want to create a dictionary. Self.dict equals dict. I want to create something to tell me if it's been removed or not. Set. A set because it still won't contain duplicates. So is remove will just tell me like if I've already removed it from the double linked list, and then I need to go through for x in nums. I would want to add these. So I'm going to call add node for it. So I'm going to create a node, initialize a node with the value x from the num. So I go through each of the numbers, and then I'll add that node, which is also going to be I need to create 2 new functions: add node self, and then it'll take node, which is a node object, and I'm pretty sure this will return none thing. Definition remove node self node, so take a node object, and I'll return none. Okay, so basically there's a set of everything. Then I also need to set my self.head equals to none, self.tail equals to none initially. Now this would be if self.head not none. I want to return self.head.data. Otherwise you're just going to return -1. To add, well, okay, let's see. First thing I'm going to do is I'm going to add node. Okay, so I'm going to add node. So if self.head is none, right? Or not and. There's two conditions. Either you have no head, in which case you want to do self.head equals to the node and self.tail equals to the node. So it's like your first element of double linked list, or double linked list has nothing. And then also I will add it to my dictionary. So self.dict node dot data value is equal to, here I want to say, okay, here I want to say it's equal to the nodes. Just put the node into my dictionary to tell me that I've seen the node. Okay, and then there's something wrong here though, because suppose a node has already been seen. So I've already seen a node, but the node is, what am I trying to say? There's a case where my double linked list is empty, but the node that I'm trying to add, I've actually already had that node previously. I just have removed it already from my double linked list because it's already not unique. So in that case, I also need to include these in my is removed. So it has to be none and node not in self.is removed. Okay. Else you would run this. Now I want to run a couple cases. So if node not in self.is, or sorry, if node is not in, if node is in self.dictionary, then that means that basically I've already seen it, so I want to remove, but I only want to remove if it hasn't already been removed, so I have to check if if node not in self.is removed. So okay, and then I'll go here, and here what I'll do is basically losing track of what I'm doing. What was I doing? I want to remove node. Not that node. I want to remove the node that's in my dictionary node.data. So the data agrees. I want to remove that node from my double linked list. Else it doesn't do anything. Else the node is not in my self.dictionary. In which case, if it's not in my self.dictionary, I would add the node how I would regularly add a node. So let's see. So I would do node, not like that, but okay. Node equals, no, not exactly. Okay. So adding node. So how do I add a node? Well, I'm going to need to basically, I'm always going to add a node to the tell. So what I would do is basically set previous tell equals self.tell. So it's what previously was my tell node. Now what I want to do is basically take the node that I have right now and set self.tell equals to this current node. And if I do that, that might work out. So I set self.tell equals to the current node. Then what I would want to do is basically set, that's good, but I want to do more than that. Okay. I also need to set self.tell so it should have a previous. The prev should be equal to the prev tell. Does that make sense? So like, I'm basically like adding this into the tell and saying that its previous value for self.tell, which is equal to this node, is going to be set to the previous tell. I should be able to do it this way as well. I could set the previous of this equal to prev.tell. And then I'm just saying that self.tell equals point to that node. And now it's in there properly. The next for that is none, because we're at the tell. Okay. So yeah, that's all. I add a node. And also, since I'm adding a node, I need to also add it to my dictionary. So I'm going to add this node to my dictionary, and that should work out. And yes. Okay. And then if we're going to remove a node, we're going to do basically, well, I think the easiest thing to do is just say next node equals to node equals to node dot next previous node equals to node dot prev. And then if next node not none, I have to make sure it's not none, then you basically want to set prev node dot next equal to next node. Sorry, this should be actually, this should be that the prev node is not none. And then there's another one is if next node not none, I'll set next node dot prev equal to prev node. So the previous one for the next node is set equal to the previous node. And then that should work for there. The other thing that I would want to add to this is the case where basically my self.head or my self.tell is equal to the node. So what if self.head, we'll just do if self.head equals to the node, well, basically you just want to set self.head equal to none, right? You're just resetting it. You have nothing. If self.tell is equal to the node, then you want to set self.tell equal to node dot. I think you want to set it to the previous. And actually, self.head would be set to node.next, my bad. Yeah, so you want to set it to the next node, which might be none, and you want to set that to the previous node. If you are, for some reason, removing the tell, right? Okay, so you have to update the tell, you have to update the head. Also, I want to add it to my set that's keeping track of what I've removed so far. So self dot, I think it was is removed. Perfect. and it's a set, so I have to do add, and just going to add values to this. So I add the data. So it's just going to contain integers. So okay, so that's perfect. So there we go. Then what we want to do is basically go to add. So what is add going to do? So add is for adding a node. Okay, so basically it's going to be adding a node. So I have to create a node, initialize a node, oops, with the value like that. The value makes my data, and then what it has to do is add the node. So that means it calls add node node. Yeah. Yeah, so it's going to add the node, and I'll do this. So I believe nope, it's invalid syntax. Right. I forgot something. We have to put is not right. But that's okay. Not in is none. So that is none and node not in. Okay. Did I do it on another line? Okay, yep, I've got is here. Okay, did I forget is somewhere else? I don't know. Name node is not defined. Okay, yeah, I'm just not going to do that. I don't need to do that. Remove node, okay. Same issue here. Since it's a class, I am not sure. Okay. Oh my god. I forgot to put self in front of all of these because I'm doing it on the object in this class. Self dot, I'm missing a self dot, okay, yeah, remove that. Alright, now let's see if this ought to work. Alright. Oh wow, okay. So I found my mistake. It was right here. Okay, so like node, that obviously isn't going to work because the dictionary, the keys for my dictionary are the ints, which are the data. So the node.data, I check that if it's in the dictionary. If it's not in the dictionary, I want to remove it. Else, I'm going to add it to the dictionary here. And so that was the major mistake. That fixes it, and then if you run submit, yep, accepted. Boom. So double linked list with like a hash table.